Well, good morning. As you can tell, I'm not with you. You've got Miss Allen today. Hi, Miss Allen. I get to be one of the fortunate ones to give the PSAT test. So, since I don't like recording a long time and YouTube limits how long you record, I'm going to get started. Got a warm-up for you. So, first question. 0 divided by 0 is equal to 0. True or false? What do you think? Yeah, I see you looking at me right there. What do you think? Well, the correct answer is false. And I have a feeling somebody on there said 0 divided by 0 is, well, you can't make a conclusion. You got to do something else. So, it's an indeterminate form, so we don't know what it is. Number 2, x plus 2 quantity squared equals x squared plus 4. Miss Allen, you can pause it if y'all want to discuss this and come up with a conclusion, or I'll give you the answer coming up right now. X plus 2 squared is x plus 2 times x plus 2, which will be x squared plus 4x plus 4. And this one, okay, so bam, bam, and we get 5 plus 2 equals 7. Do you agree that number 3 is true? Do you? I don't. That's math jail right there. I only canceled from one term. If you're going to divide x plus 3 out, you have to divide it from everything, so that is false. Number 4. Finally a true answer. And number 5 looks a lot like the definition of the derivative. Do you agree that that one's true? I tried to trick you on this one. It's false because we're missing the limit in front of it. If it had had limit in front of it, then as h goes to 0, then it would have been true. Okay, moving on. So today we're learning one of the first major rules that goes along with derivative after the power rule, when we have to learn the product rule. When you have a function times a function, we can't just take the derivative of each piece. There's a special way you multiply them. Like this right here, the derivative of u times v, depending on what u and v are, well, it's v times the derivative of u plus u times the derivative of v, or the more popular way to say it, first times the derivative of the second plus second times the derivative of the first. One way to look at it is if you were to make u and v in a box, like I have up here at the top, you put u here and v here and take the derivative of each of those below it, this times this plus that times that, and it doesn't matter where you start. So, one of the advice I tell people to do is if you're going to do the derivative, like on number 1, we're going to I'm going to split, whoops, it's not supposed to be straight up and down. I didn't draw that very well, so let me draw that straight, a little bit, I've got my board a little crooked, I guess I need to turn a little more. Let's take the derivative of each part here. Derivative of this part, if you need to, pause it, talk about it with your neighbor, y'all figure out the derivatives, come back when you're done. Okay, hopefully you came up with those right there. And now if we take this times this and that times that, we're going to end up with, well, let's write that all out. 2x cubed minus 5x plus 3 times negative 2x. It would have been better writing that in front, but oh well. Plus, product is a plus. Keep that in mind. And the other one's going to be 6x squared minus 5 times negative x squared minus 2. That parentheses around the x squared is not necessary because the negative out front would only become positive if the negative was inside there. And since it's out front, it's just negative x squared. This is still the same thing. That is not a positive x squared. And you noticed it doesn't matter which one of these two I put first and which one I put first there. When you're adding, this product plus this product is going to give you the same result, because that's called the commutative property. Doesn't matter which one, and inside there you can commute the multiplication. It doesn't matter which term I put first inside each one. So anyway, let's multiply this all out, and I'm going to cheat and look at my answer, so I don't do all this by hand, because I don't want to make a mistake. Negative 4x squared plus 10, oh no, 4x to the fourth. Darn it, I don't want to make a mistake. It's a mistake, and I already did. Negative 4x to the fourth plus 10x squared minus 6x minus 6x to the fourth plus 5x squared minus 12x squared plus 10. So y prime was equal to all this, so y prime is still equal to that right here. And so that is now equal to, if I simplify that down, negative 10x to the fourth plus 3x squared minus 6x plus 10. And there's the answer to number 1. First times the derivative of the second plus second times the derivative of the first. That is the important information you need to know. Let's go to number 2. Number 2, instantaneous rate of change. That right there should seem like a very familiar term to you. That means find the derivative at a specific value, in this case at 4. So, I'm going to rewrite f of x just to make it a little simpler, because if I write it as a power, it'll be easier for somebody to figure out. 3 squared of x is 3x to the 1/2 power times 2x squared minus 5x. And if I make my little lines, whoops, and put my derivatives below those, this would be 3/2 x to the 1/2 minus 1 is a negative 1/2, and then 4x minus 5. And so my derivative, let's go back to blue, f prime of x is going to equal to 3x to the 1/2. Now, sometimes it's better to start with this one because it'll prepare you more for the quotient rule, but it doesn't really matter for product rule. 3x to the 1/2 times, and we got more than one thing, so I'm going to put the more than one stuff in a parentheses here, the group, plus, and on this one we've got 3/2 x to the negative 1/2 times 2x squared minus 5x. And if you have any questions while I'm simplifying this, Ms. Allen can pause it and walk you through how to do that. But we're going to distribute, and we could distribute, or we really wanted f prime at 4. If we plug in 4, sometimes it's easier to evaluate these. Instead of trying to simplify all this down first, sometimes it's easier to work with numbers. So we can plug in the numbers, and that would be 3, well, x to the 1, so 3 squared of 4 times 4 times 4 minus 5 plus, that's 3 over 2 square root of 4, in case you didn't remember, that's where that came from, times 2 times 4 squared minus 5 times 4, which would simplify down to 3 times 2 times 11 plus 3 over 2 times 2 is 3/4 times 32 minus 20. I'm cheating and not working this all out. I'm looking at what I've already done before. And when you simplify that down, you get 66 plus 9 and 75. And there's number 2. Let's go on to number 3. I wonder what time is it. Let's see, how much time? It's been 8 minutes and 42 seconds in case you're curious, and I wanted to try to get at least product rule done in 10 minutes, so it means I've got to hurry. Number 3. Another table, I like these. We got Q is equal to R times T, and we want to find the equation of the tangent line. So tangent line means we've got to do a derivative again. So we need a point. So we got 3 comma something, but we don't know what the other part is. So we need to find out what Q of 3 is. Well, Q of 3 is going to be equal to R of 3 times T of 3, because that comes from this right here. And R of 3 is negative 4. T of 3 is 2. So it looks like, if I did my math correctly, Q of 3 is equal to negative 8. And somebody's at the door, so I'll pause it and I'll be right back. We all can blame that on Miss Witt can't come into the door to bother me. Gosh, you just can't do anything without interruption these days. I kid. Hey, I changed one thing about me. Can you tell what's different? Anyway, well, I don't see me making it under 10 minutes since I'm at 9 minutes and 40 seconds just a second ago. So we got the point, 3 comma negative 8. Where'd my pen go? Oh, whoops, there's my pen, negative 8. Now we need a slope. Slope comes from the derivative, so I need q prime. And if you try to do q prime as r prime times t prime, you're wrong. Shame on you. Because we just learned you can't take a function times a function to get a derivative. It's going to be the first times the derivative of the second, plus the second times the derivative of the first. And so that's equal to r of, and we wanted q prime, we're finding the derivative at negative 3. So that's going to be r of negative 3 times t prime of negative 3 plus t of negative 3, whoops, that's not up there, it's down here, t of negative 3 times r prime of negative 3. And that all comes from our table. R prime of negative 3 is r of negative 3, sorry, is negative 4, not equals, negative 4 times t prime of negative 3 is 3, plus t of negative 3 is 2, and r prime is negative 2, and we end up with, looks like negative 12 minus 4, and we get negative 16 for a slope. So, did I do that right? I'm checking my work. Yep. So, oh, my key, I stopped there. But they didn't say stop at slope. It said find the equation of the tangent line. So now we've got to use our good old point slope formula. Y minus y1 is equal to m times x minus x1. And so we end up with y plus 8 equals negative 16. X minus 3, and we are done. You don't have to rearrange it unless you just really want to, and I advise against it because too many people make mistakes. And the final one, number 4. We've done it from an equation, we've done it from another equation, we've done it from a table, and now we're going to look at it from a graph. And let's see, so for this one, if I need to find v prime of 5, and I have a feeling you're going to see graphs like this in the future on, who knows, maybe a test or something sometime. So, let's see, v prime of x. The derivative is going to be equal to the first times the derivative of the second, plus the second times the derivative of the first. So, v prime of 5 is going to be equal to f of 5, that's a y value, times g prime of 5, that's a derivative, which from a graph is a slope, plus g of 5, which is a y value, times f prime of 5, which is a slope. So, if these points line up, I need to know what's going on over here at 5. I need that point, which looks like 5 comma 1. And I also need its slope. That line looks like it goes up 1 over 1, up 1. Let's see, no, that's the one. Yeah. Up 1 over 1, up 1 over 1, because we went negative 1. Yeah, so slope of 1. This point, g of 5, so this is the point for f. The point for g looks like 5 comma negative 2. So there's g. And then the slope for that line here is, that slope is, what is that, up? We went from 4 to 0, 4 over 2, so slope of 2. So, v prime of 5 is equal to f of 5. F of 5 is 1 times g prime. G prime is the derivative, and the derivative of a number is the slope. So, and the slope of a line is the slope. The slope of the tangent line is the slope of the line. Sorry, I'm talking fast. I'm running over time. So 1 times 2 plus g of 5. G of 5 is negative 2 times f prime of 5 is 1. So it looks like we have 2 minus 2, and we get 0. V prime of 0 is this exact same process, but instead of 5's here, you put 0's here. So for part B, V prime of 0 is going to be equal to f of 0 times g prime of 0 plus g of 0 times f prime of 0. You try it while I'm writing this down. You try to work this, Ms. Allen. You can pause it if you need to. You'll try to figure this out, And when you get stumped, which you probably will, or you might know the answer, come on back. F of 0